Every time your phone talks to a cell tower, it has to prove who it is. But here's the problem. If it just announced its real permanent ID every single time, anyone with a cheap radio scanner could sit outside your house and track exactly when you're home, when you leave, and where you go. So mobile networks came up with a clever trick. Instead of using your real identity over the air, they hand your phone a disposable alias. A nickname that changes constantly, means nothing to an outsider, but still lets the network find you instantly. Today we're going to unpack that system, from the earliest version, called TMSI, all the way to its modern LTE successor, the GUTI, and every piece hidden inside it: GUMEI, MMEI, MMEC, MMEGI, and STMSI. By the end, you'll understand exactly how your phone stays reachable without ever giving away who it really is. Let's start with the identity underneath all of this. The IMSI, the International Mobile Subscriber Identity. Think of it like your passport number. Permanent, globally unique, tied to you and only you, stored on your SIM card. The network absolutely needs it to know who you are. The problem is exposure. If your phone broadcasts its IMSI on every single connection, over open radio waves, anyone listening nearby could log it, track your movements over weeks, or even impersonate your device. That's why the golden rule in mobile networks is simple. Use the IMSI as rarely as humanly possible, really only the first time a phone attaches to the network. For everything else, calls, texts, data, paging, the network needs a stand-in, a throwaway name it can use instead. That stand-in is exactly what we're about to build, piece by piece. In 3G networks, that stand-in was called the TMSI, the Temporary Mobile Subscriber Identity. The key word here is temporary. A TMSI is just 4 octets, 32 bits, and the network can reassign it whenever it wants. Every time you move, every time you reconnect, sometimes just at random intervals. But here's the detail that matters most. TMSI has only local significance. It only means something within one SGSN. That's the node managing a particular area of the network, and within the geographic zone that SGSN controls. Carry that same TMSI to a different SGSN's territory, and it's meaningless gibberish. Nobody outside that local zone can connect it back to you. So even if someone intercepts it, they've captured a name that expires the moment you cross into new territory. That's clever. But 3G networks were simpler, with fewer moving parts. When the industry moved to 4G LTE, the architecture got more distributed, with many more network nodes talking to each other. And that meant the identity system needed an upgrade too. Enter the GUTI, the globally unique temporary UE identity. LTE's answer to the same privacy problem, but built for a bigger, more distributed network. Here's the part that matters. GUTI isn't just a random number like TMSI was. It's engineered with structure so that it does 2 jobs at once. First, it uniquely identifies you, the device, just like before. But second, and this is the clever upgrade, it also encodes exactly which network node is responsible for you. Structurally, GUTI splits into 2 main components. One half is called the GUMEI, that stands for Globally Unique MME Identifier, and it pins down exactly which MME, the LTE control plane node managing your connection, issued this identity. The other half is the MTMSI, which uniquely identifies you, the UE, within that specific MME. So think of GUTI like a well-organized shipping label. One part says which warehouse handled the package. The other says which exact box it is inside that warehouse. Let's zoom into each half, starting with the GOMMEI. The GOMII's whole job is to answer one question. Which MME allocated this identity, anywhere in the world? To do that globally, it needs to name 3 things nested inside each other. First, the MCC, the Mobile Country Code, which says which country your network operator is in. Second, the MNC, the mobile network code, which says which specific operator within that country. Think Verizon versus AT&T or Vodafone versus EE. Together, MCC plus MNC form what's called the PLMN ID, the Public Land Mobile Network Identifier. Basically, which carrier in which country. But knowing the carrier isn't precise enough. A carrier runs thousands of MMEs. So the GOMII adds a third piece, the MMEI, the MME identifier, which narrows it down to one specific MME node within that operator's entire network. Country, then operator, then exact server. That's the GOMII, a globally unique address for the one MME that knows who you are. Now let's open up that MMEI, because it's not just one number either. It's built from two smaller pieces designed for how real networks are organized. Picture a carrier's core network as a set of MME groups, each one covering a region with several MME servers inside it, and each of those MMEs connected to a cluster of ENBs, the actual cell towers your phone talks to. The first piece of the MMEI is the MMEGI, the MME group ID, 16 bits, which says which group of MMEs you're dealing with, like picking the right office building. The second piece is the MMEC, the MME code, just 8 bits, which picks the exact MME within that group, like picking the right floor in the building. Look at the diagram. ENB1 through ENB4 are the towers on the ground, each linked up to MME1 or MME2, and both of those MMEs live inside one MME group labeled with an MMEGI. So MMEGI gets you to the right group. MMEC gets you to the right MME inside it. And together, that's the full MMEI. So the GUMMI has done its job. It's pointed at one exact MME, anywhere on Earth. Now we need the other half of the GUTI, the MTMSI. Once we know which MME is in charge, the MTMSI is simply the label that MME uses to tell you apart from every other device it's currently serving. Its own private identity, uniquely yours within that one MME. But there's one more piece worth knowing, the STMSI, the shortened version. Full GUTI is great for globally routing between operators and countries, but for everyday tasks happening entirely inside one MME's territory, like paging your phone for an incoming call, or a quick service request, broadcasting the entire GUTI over the air is overkill. So the network shrinks it down. STMSI is just the MMEC plus the MTMSI, dropping the country and operator info, since within one MME's own area, everybody already knows which MME they're talking to. It's the same idea as TMSI in 3G, a fast, local, lightweight tag, but now built as a clean subset of the bigger GUTI system. Let's put the whole structure together and look at the actual bit sizes, because the numbers tell a story of their own. The full GUTI is 32 bits of GUMME plus 32 bits of MTMSI. Inside that GUMME, MCC and MNC identify the operator. Then a 24-bit MMEI pins the exact MME. And that MMEI itself splits into a 16-bit MMEGI and an 8-bit MMEC. Notice the group gets twice as many bits as the code, because there are far more possible groups than MMEs you'd ever pack into one group. And the shortened STMSI? Just the 8-bit MMEC riding along with the 32-bit MTMSI. Compact enough to broadcast constantly for paging without ever leaking your permanent identity or your exact operator and country to a casual listener. Every layer of this design has a purpose. Enough detail to route your traffic to the right server anywhere in the world, but never more detail than an eavesdropper would need to actually identify you. So let's zoom back out. Every time your phone connects, it's playing a careful game. Stay reachable, but stay anonymous. In 3G, that meant a simple, locally valid TMSI, meaningless outside its own zone. In LTE, the network needed something smarter for a bigger, more distributed system, so it built the GUTI, a GUMMEI that routes precisely to the right MME anywhere on the planet, using country, operator, and group plus code, combined with an M-TMSI that names you within that MME. And when speed matters more than global reach, like paging, the network just shrinks it down to the S-TMSI. None of this ever needs your real IMSI, your permanent passport-like ID. That stays locked away, used only in rare, secured moments. That's the real magic here. An entire global network can find you, route your calls, and page you for a text message, all without ever saying your real name out loud.